In this video, I want to have a look at differentiating sin x from first principles. So we've already been differentiating sin x and we know that its derivative is just cos x, but we actually want to go through and prove it. Now in this proof, we're going to use a rule or an identity that we haven't seen before, and that's this. If we have sin a minus sin b, it can be rewritten into this form. Now, like I said, we haven't used this before and we haven't proved it, but you can go through and prove it to yourself just by taking this right-hand side and expanding it, and you should end up simplifying down to that left-hand side. All right, so let's jump straight into it. So if we say that f of x is equal to sin x, then we know if we're differentiating from first principles, then we're going to take the limit as x approaches, as h approaches 0 of f of x plus h minus f of x over h. So substituting things in, we're going to have the limit as h approaches 0 of sine of x plus h minus sine x over h. So this is where we're going to use this rule. So for us, we're going to have that x plus h, that's our a, and then we're going to have the x as our b because we've got sine of something minus sine of something else. So if we rewrite that, we're going to have the limit as h approaches 0 of 2 cos x plus h plus x over 2, and then sine of x plus h minus x over 2, and that's all over h. So if we go through and simplify that down a little bit, we're still going to have the limit as h approaches 0 of 2 cos, and if we simplify what's in here, we're going to have 2x plus h over 2, and then we've got sine of the x is cancelled, so we'll just have h over 2, and that's still all over h. So I'm going to break that up a little bit now. So we're still going to have limit as h approaches 0. I'm going to just take this bit out, and I'm going to put the 2 and the h, I'm going to attach that to the sine instead. So I'm just rearranging this. And in that cos, I'm also going to break this 2x plus h over 2. I'm going to take that one function, I'm going to break it into 2. So that 2x over 2 would just give me x, and then I'll have plus h over 2. And I've got that times 2 sine h over 2 over h. Now what I want to do with this bit, we know that the limit as h goes to 0 of sine x over x goes to 0. Goes to 1. So I want to make this denominator look like that numerator. So if I want to change that into a h over 2, that means I'm dividing by half in the denominator. So I'd have to times by half out the front. And a half times 2, that'll just cancel those out. So then when we take this limit, we have the limit as h approaches 0 of cos x plus h on 2. So this h on 2 is going to go to 0, and this part is just going to leave us with cos x. And we know that when we take the limit of sine h over 2 over h over 2 as h approaches 0, this whole section here is going to go to 1. So that whole limit is just going to give us cos x. So that's differentiating sin x from first principles.